Hello friends. In this video, we are going to write a small C++ program that converts a temperature from Celsius to Fahrenheit. The formula itself is something you have probably seen in school. Fahrenheit equals Celsius times 9 divided by 5 plus 32. Simple math. But here is the interesting part. The moment you ask a computer to do this, you have to make a real decision about how to store these numbers. Whole numbers or numbers with decimals. That one choice changes whether your program gives you the right answer or a completely wrong one. So let me show you the code, walk through what each line is doing, and along the way, we will see what is actually happening under the hood when the CPU runs this math. Let's jump in. Alright, here's the full program. It is short, about 10 lines, but every line is doing something specific. So let me give you the lay of the land before we zoom in. At the top, we include IOStream, which is the standard input and output library. That is what gives us cin and cout. Then we have our main function, which is where every C++ program starts running. Inside main, we declare two variables, Celsius and Fahrenheit, both as float, and that float keyword is going to matter a lot in a moment. We print a prompt asking the user for a temperature, read their input into Celsius, do the conversion math, and then print the result. Finally, return 0 tells the operating system the program finished cleanly. That is the whole shape of it. Now let me show you the two lines that actually do the work. Now look at these three lines. This is where the actual work happens. First, we declare Celsius and Fahrenheit as float. Float means a number that can hold decimals, like 36.6 or 98.4. And this is the key decision in the whole program. If you had declared these as int, you would only get whole numbers, and the math would break. Here is why. The formula multiplies by 9 and then divides by 5. If Celsius is an integer like 100, the computer does 100 times 9, gets 900, then divides by 5, gets 180. That works out cleanly. But try 37. You get 333 divided by 5, which should be 66.6. But with integers, the computer just throws away the decimal and gives you 66. That is integer division, and it silently loses precision every time. By using float, we keep the decimals, and the math stays accurate. The next line, cin, reads what the user types into Celsius. And the line after that runs the conversion and stores the answer in Fahrenheit. Simple. But the data type made all the difference. Alright, now the program just needs to show the answer. The cout line prints the word Fahrenheit, followed by whatever value is sitting in our Fahrenheit variable. And return 0 at the end tells the operating system everything ran successfully. That 0 is basically the program's way of saying, all good, no errors. Now let me show you a sample run. The program prints, enter temperature in Celsius. The user types 37, which is roughly normal body temperature. The program multiplies 37 by 9, gets 333. Divides by 5, gets 66.6. Adds 32, and the final answer is 98.6. Which, if you have ever taken your temperature in Fahrenheit, you will recognize instantly. That is exactly normal body temperature in the Fahrenheit scale. The math checked out, the float kept our decimal precise, and the program did its job in under 10 lines of code. Before we wrap up, here is the part most beginner tutorials skip. When you wrote float, the CPU did not just store 37.0 as a number on paper. It packed it into 32 bits using a standard called IEEE 754, 1 bit for the sign, 8 bits for the exponent, and 23 bits for the fraction. That is why float has limits on precision. For temperatures, it is more than enough. But the same reason your program works smoothly here is also why floating point math sometimes gives slightly weird results in bigger calculations, something we will explore in a future video. Quick recap, use float when you need decimals. Cin reads input, cout prints output. And watch out for integer division, it silently drops the fractional part. That is it for this one. If this helped, hit like, subscribe to Webronaq, and drop a comment if you want me to cover the heat index formula next. See you in the next video.